video for 4-4, adding and subtracting rational expressions. And with this, we have our essential question: how do you rewrite rational expressions to find sums and differences? So we're going to use the same rules that we did whenever you add fractions together that don't have letters in them. They do have to have the same denominator in order to add or subtract the numerators. So if we look at part A of example 1, it's asking us for the sum, so we have addition as our operation. Both of the denominators are x plus 4, so that is going to carry through into my answer. And since the denominators are the same, I can go ahead and add the numerators together. So x and then plus 5 is going to be x plus 5. And that is my solution. There is nothing else I can simplify. There is nothing else we can do with this problem. The x's are attached by addition to the 5 and 4 respectively, so we cannot go through and cross them out. You can only cross out things that are factors, so just please make sure you're aware of that whenever you're working through these problems. With part B, it may look like the denominators are different here, but actually we can factor in x out of the first denominator, and that becomes x times x plus 3. And so those denominators are actually the same thing, which means x times x plus 3 is going to be the denominator of my answer. So now we have to go through and combine the numerators together. 2x plus 1 plus 3x minus 8, well, 2x plus 3x is 5x. 1 plus negative 8 is negative 7. Do check to make sure that there is no greatest common factor in your numerator. This one does not have any, so this would be your solution. Again, there's nothing I can cross out, there's nothing I can reduce here. These are two additional examples, both of addition and I've thrown a subtraction question in here, where we need to simplify, which means I need to combine my terms together into a single fraction. So for part A, I do have the same denominator. So I can go ahead and copy that down. I am adding, so the numerators I need to combine together. X plus 6x is 7x, and then 2 plus 6 is 8. You do want to make sure that everything is factored as far as it can go. So, for example, 7x plus 8 has no common factor, so it would have to stay the same way. However, on the bottom, 24x minus 36, I can take a 12 out of both of those, and I'm left with 2x minus 3. Now with this one, it doesn't actually matter because there's nothing that's the same in the top and in the bottom. And by the same, I mean the same factor. It has no factors that are the same in the top and in the bottom, so I can't actually reduce this. This would be my final answer. Part B is a little bit tricky because we do have to consider the fact that we're subtracting. So you are subtracting the entire numerator from the first numerator. They both have the 18x squared minus 9x as the common denominator, but whenever you're subtracting, you're not just subtracting the first term in this second numerator here, you are subtracting both of those terms. So I'm going to rewrite the top. I do have the x minus 2, but then it's going to be a minus x minus positive 6 is going to be a minus 6. So you can see here I'm subtracting both the x and the positive 6. They both change sign. The subtraction is where students usually make errors because they don't remember to carry that subtraction through the entire numerator. They only use it with the first term. So let's go through and combine terms. And the denominator, we can factor something out of that. 18x squared minus 9x, I can divide those both by 9x, and I'm left with 2x minus 1. On the top, x and minus x add out. Negative 2 minus 6 gives me a negative 8. There's nothing that I can divide out, nothing I can reduce. So that would be my final answer for that one. So far we've looked at questions where we already had common denominators. Now we're going to look at what to do whenever your denominators are not the same. So we're going to look at two where we have monomials in the denominators, and then we're going to look at one where we have a full-blown rational where we have factors in the bottom. So for part A, I have 6 over 2y plus 3 over 6. You do want to make sure that you reduce whatever you can reduce first. That'll make things a little bit easier to work with. So the 6 over 2 can reduce to a 3 and a 1. So that's going to become 3 over y. And sometimes you may not be able to reduce, but always look for it first. The 3 over 6 is going to reduce to a 1 over 2. And now I can look for my least common denominator. Your least common denominator has to include all of the factors that are present in both denominators, but you don't repeat factors. So for example, if y appeared in both fractions, I wouldn't repeat the y, I would only use it once. Well, my least common denominator is going to be a 2 and a y. Now we have to multiply to make my denominators the same. They have to be both 2y. Well, the first fraction only has a y. It's missing a 2. So I have to multiply the top and the bottom by 2. The second fraction has the 2, but it's missing the y. So we have to multiply the top and the bottom by the y. So now I actually multiply 2 times 3 is 6. And in the bottom, well, notice it goes back to 2y. So that one, it probably wasn't a good idea to reduce, but you always want to make sure you're in lowest terms anyway. The second fraction on top, I'm going to have 1 times y, which is y. On the bottom, 2 times y is 2y. And you see it made more sense to reduce the second fraction because it looks a lot different than the original. So now we combine. Again, the denominator, when you add things or subtract them that have the same denominator, you only use the denominator once. So 2y is going to stay what my denominator is. And then on the top, 6 plus y is 6 plus y. That cannot combine into a single term. They are not like terms, so I just put them next to each other, but I'm not actually going to make them a solitary term. There is no common factor on the top, so there's nothing I can divide out with on the bottom. That would be my solution. Part B, again, I can go through and reduce things. The 2's can both turn into 1's because they divide out. There's an n in the top and an n in the bottom, so I can reduce those, and I'm left with 1 over m. The second fraction has no terms that divide out in the top and in the bottom, so that's going to stay 5 over 2n squared. So my least common denominator, again, it has to include stuff from both denominators. The first denominator has an m, the second one has a 2n squared. Nothing is shared, so 2n squared is going to be my least common denominator. Well, the first fraction is missing the 2, and it's missing the n squared. So I have to multiply by both the 2 and the n squared on the top and on the bottom. And I don't think I discussed this, but the reason why we multiply on the top and on the bottom is because when you have the same thing on the top and on the bottom, that's 1. And when you multiply something by 1, it does not change value. Even though it might look different, it's still exactly the same fraction. Now the second fraction has the 2 and the n squared, but it's missing the m. So I would multiply by the m on the top and on the bottom. So my new first fraction numerator is going to be 2n squared. The denominator, 2n squared. Typically, we write variables in alphabetical order, so you would put the m before the n squared. Second fraction, the top is going to become a 5m. The bottom is going to be 2mn squared. And then I combine my numerators together. So I have 2n squared minus 5m. There's no common factor on the top because my letters are different. No number is a common factor, so there's nothing I can do with that. That is simply your final answer. The last question we're going to look at is simplifying whenever you have binomials in the denominator. So we have 5 over k minus 5 plus 5k over k plus 5. As long as your denominators are as simplified as they can be, so if they need to be factored, they've been factored, your least common denominator is going to be whatever denominators you have. Again, we wouldn't repeat terms. If they shared a denominator, you would not repeat that, but these are different because one has the plus, one has the minus. So now, just like we did before, we're going to multiply by the missing piece. The first fraction has the k minus 5, but it's missing the k plus 5. So I have to multiply on top and on the bottom. The second fraction has the k plus 5, but it is missing the k minus 5. You do not have to FOIL your denominators. You can leave them as the two sets of parentheses. In fact, I highly suggest you do not multiply them because it'll make it more likely that you'll see if something needs to cross out in your solution. So the k plus 5 times 5, I have to distribute that 5. That's going to give me 5k plus 25. The second fraction, I have to distribute the 5k to the k minus 5. That's going to be 5k squared minus 25k. And then I can go through and combine my tops together. This is in addition, so you don't need to worry about changing anything to its opposite sign. So on top, I'm going to write these in their proper order, so the square term would go first. There's only one of those. I have a 5k and a minus 25k, which is going to give me minus 20k, and then 25 at the end. Now, the numerator does have a greatest common factor. I can divide all of those by 5, so I am going to take out that 5. Now I have 5 times k squared minus 4k plus 5 on the top. Normally at this point you would see if that can factor further. However, just by glancing at it, there are no factors of positive 5 that equal negative 4. To make it negative, I would have to have 2 negative factors, so that would leave me with negative 1 and negative 5. And those add to negative 6, not negative 4. So the top does not factor further. There's nothing we can divide out with what's on the bottom. So that would be your solution. That would be your final answer. This section can be a little bit tricky, but I do want to make sure that you go through and practice and give it your best effort. So please go back through, rewatch any part of this that you need to go back and rewatch, take notes as needed, and reach out if you have any questions.